Welcome to another CES video, MATLAB in the Middle East. Today I will show you the new features in the MATLAB 2021b release. I will start with the run functions in background. So in this example, you see how to run a function in the background with using this part for evaluation and the background tool. And you can use this function even if you don't have the parallel computing toolbox. Okay, so it's called also asynchronous functions, and either you run your code synchronously or asynchronously. So I will show you both. The first one is going to be we have two matrices here, a random matrix A and another of ones B, and we have C using both matrices in the function matrix. And also we have tick and clock just to measure the time this will. Okay, so let me just run it and you'll see. So this function took 1.03 seconds. So and this is the workflow of the processing. So not one is the A, so we are calculating the random of 10,000 by 10,000 matrix. We have B, the ones matrix in the foreground. So after we run is sequential. So we run first number one, after B, and third is going to be the operation of C. So using A and B in the foreground. Everything is in the foreground. So now let's jump to asynchronous code. Here I'm going to use the function bar for evaluation, and also in this way, in this syntax, we can provide the background pool and the function we want to run inside it. Let me just run it and you will understand. So here it took 0.48 seconds, half of the, less than half of the time. So what happened here exactly is bigger, okay, so we can see the code, and also we can see this workflow. So here we have one is going to happen, first is going to happen A, random matrix, 10,000 by 10,000 in the background, because we're using this functionality. This is the number one, so calculation number one. In the foreground, we're going to calculate B. We're going to create the matrix B of 10,000 by 10,000 ones. And 3 is going to be the operation C. So what happened here? We have 1 in the background and 2 in the foreground. And what's going to happen here is we're going to wait until FA is evaluated. So we have the result of this to go to the C operation. So here we provide the fetch output of the evaluation here in B. So in the end, you're running this in the background and one in the foreground, and that's why it's faster. You see the result is less than half of the time. Okay, so how to use these functions? If you don't have parallel computing, you can use one worker in the background. This means that you can use one core of your processor to do this task in the background. If you have parallel computing, so you can run multiple workers. So if you have the maximum number of workers is 8. For example, if your machine has 4 cores, you can run 4 workers. But if your machine has 16, you can run maximum 8 workers. So I encourage you to use this function. It's very handy, and you're gonna speed up your script. Now let's jump to decompose data using the trend composition function. It's a new function. I will create a vector here of 1 to 200, and I have an operation to create a trend, and I have 2 periods to use in a seasonal period, and I will introduce some noise, and I will sum all this trend, the seasonal data, and the noise to a table. Let's just do this first and you'll understand. So here I have my data for the seasonal, for the trend, noise. So I will create the table T. And here you have the table T, we will plug in this data. Okay? We can use the function trend decomposition. The same period of the information we have, the season, and we're going to use in this case the STL. STL stands for the seasonal trend decomposition. It's an algorithm. It's the reference of it, but also you have another algorithm you can use. So what do we see here? We have the trend signal here, long term. We have the seasonal trading. So the original data is you can find it here. Time and season. And we can extract the long-term trend and the seasonal trend. If you see the seasonal we extracted is exactly the same seasonal here. And the result here of the data remainder is exactly the noise we introduced to it. So we're going to extract the long-term seasonal trend and the noise of this data. So it's very handy to use if that's this kind of data. Okay. Now let's jump to the new live scripts tasks. So if you don't know, here we have in Live Editor tasks. We have so many tasks for data visualization, data preprocessing, tables and tables. Now we have the statistics and machine learning clustering, optimization, and some other tools. Here we are going to talk today about normalized data and compute by group. These are the new tasks and also the cluster data. Let's go. I'm going to change my visualization. So here you see the result on the right side. So I will use the noise data I already have in my workspace. So here, what I'm doing, I am using the noise data, and I can use, in here I see the visualization of my input data, the noise data, and here is the normalized data. So I'm using this, you can use the z-score. You see it's normalized in 0 and goes up and down. So you have the standard deviation or median absolute. You can use these two methods. So you have normalization, range, median, center. You can center your data. You can use scale as well if you want, or you use both of them. So you can use mean and standard deviation. Okay. So this is, you can, and in the end, your data will be inside this normalized data in your workspace. After you use this task, you can see the code of everything. For example, you only need to provide this your code, copy and paste of the how to normalize the data. If you want to have the plot, you can copy this display results. Okay. Now another task I want to show you is compute by group. So here I'm loading the data from patients. This is inside the MATLAB, so you just can run this. And I will create a table using gender, age, smoke, and location. Let me just run this. So what I want to show you here, we have the table of gender, age, smoke, and location. So you can apply groups to it. For example, here we have my table is T. I want to pick the genders, and I will see the result table here. How many genders? Female 53, male 47. You can use the age as well, the age of these groups. You also can include one more of gender. So you're going to have the gender and the age groups. You can also transform by group. For example, you want to normalize, or you want to will missing data with group. And also you can apply functions to this group. So here we can apply this filter by group. I filter who has age higher than 40. So my 44 is going to be my table with people more than 40 years old. And you can use this task to complete groups. But you're going to have the results here in the code how to create the group. And then now let's jump to clustering. So you have this task called cluster data and apply Cummings algorithm. So here I bring the data from the feature iris dataset. And here we can see I have a cluster of 3 and it says 3 data sets. So I need to select actually the data. It's going to be dismissed. So here I can create manual or optimal clustering, and I know we have 3 clusters. So if you want to make 2 clusters, it's going to be this the result. If I include one more, it's going to update the plot. Every time it's green here, it's going to auto run every modification you use in this class. Okay? So if you have one more, we can see this the result. But we know we have only 3 classes in this. Okay? And you have also evaluation methods and more data we can use. So you can find the optimal. Okay. So now also you have the data generated by class. Now let's jump to Python. There is a new function called run Python statement from MATLAB. First, you need to, if you don't have Python in the path of MATLAB, so you can improve it by doing this. So it's Py version, and you need to provide the location of your Python executable. So it's here. After you do it one time, you don't need to do it again. So what is Python? Click right, help, you see this small window, Python statement. So here you can show what you need to, how to use the syntax code, the outputs you want, or the inputs you want to provide. So it's like this. Okay. So bigger. Okay. So let me run this hello world. So here I have my data is actually greeting equal to this, so I want to print greeting. So and hello world is here. So this is running inside MATLAB. So now this executes a statement A equal to B times C. So I need to provide the expression I want to calculate. The inputs 5 is going to B and C is going to be. Okay. Run this code. So here I don't see the output because I didn't request the output. So when you request the output, it's different. In this case, if A and B and C exist only in the Python namespace, you can just use the Python one to run another expression. So B equal to A and C, you're going to provide A, B, and C. It's already there in memory space. So now you want to calculate it. So if you want to compute the output, remember to always put this after the expression, the output and the inputs. So if you want to know more about the new features in MATLAB 2021b, I encourage you to go to this website, and there you can find all the new features for MATLAB and all the toolboxes. Okay. I hope you like this video. Thank you very much. See you